Okay, this is Graham's law, using relative effusion rates to find an unknown molar mass. So what's happening here is it's comparing the rate of our unknown gas, which we're going to call A, we don't know what that is, to a gas that we know, which is going to be B. And in this case, B is argon. So we've luckily been given the rate of the speed of escape of gas A compared to gas B, which in this case is going to be argon. Okay, so we are able to then look up the molar mass of gas B, which is argon, molar mass B, which is argon. So you can just use your periodic table, okay? So argon has a molar mass of 39.95 grams per mole. So then we can just plug and chug this ratio, which is rate A over rate B is this 1.4 times. And a little thing that can help you out as well as far as the wording goes here. So we've got that this mystery gas escapes 1.4 times as fast as the argon gas. So what that's actually telling us is about that ratio, okay? So with that ratio, if it is more than 1, that is telling us that our unknown gas must be lighter than argon, okay? So if our ratio is more than 1, okay, our unknown gas is lighter, okay? And if our ratio is less than 1, our unknown gas must be heavier for us to get a value that is like decimal, right? Less than 1. Okay, so let's do it then. So we're just going to plug and chug. So 1.4 is our rate A over rate B. And then we've got our molar mass of argon. That's 39.95 grams per mole, divided by our molar mass of our unknown gas. Okay, so we're just going to rearrange that real quick. So because I've got the square root of the whole right-hand side of the equation, the best thing to do is square both sides, okay? So you're going to end up with 1.40 squared on the left-hand side equals 39.95 grams per mole divided by the molar mass of A, okay? So then if I times both sides by the molar mass of A and divide both sides by that 1.40 square, I should get the molar mass of A equals 39.95 grams per mole divided by that 1.40 squared. Okay, so then I'm just going to stick that in my calculator and hopefully I get a reasonable number, and it's going to come out in terms of units of grams per mole. And let's see what that is. 39.95 divided by, be careful with parentheses, 1.40 squared gives me 20.38 grams per mole. Now, this is where you have to be a little bit careful, okay? It's very important to look in the question. We've been told the gas is made up of atoms. So this molar mass here should correspond directly to the molar mass in the periodic table of our unknown because it's just found as atoms. So the first place to look should be your noble gases, okay? Because we know the noble gases don't form homonuclear diatomics. And if I look, neon has a molar mass of 20.18. So 20.18 is close enough for me. So I would say that the gas has to be neon, okay? So I just want to show you another variation of that question where it doesn't say the gas is made up of atoms. Let's look for one. Made up of atoms, yada, yada, yada. Made up of atoms. Come on, give me one where we have a homonuclear diatomic molecule, okay? So what I'm looking at is, let's see, let's get rid of some of this right here. Blah, blah, blah. This bit right here, homonuclear diatomic molecules. So that is your things like O2, N2, F2. There's 7 of them that you're supposed to know. Have no fear of ice cold beer, right? So hydrogen, nitrogen, fluorine, oxygen, iodine, chlorine, bromine, okay, but we know that iodine and bromine are not gases at room temperature and pressure, okay, I'll leave it there. So again, it's going to be heavier than krypton gas because that ratio, sorry, it's going to be lighter than krypton gas because that ratio is more than 1, okay. So what we do is we solve it in the same way, but just be careful at the end because that molar mass you're going to get is for the formula X, whatever the unknown gas is, subscript 2, okay, because it's a homonuclear diatomic. It's made up of diatomic molecule. So it's two atoms, the same identity bonded together as a molecule. Okay, so rate A over rate B is 1.49. Okay, that is the square root of the molar mass of krypton, which is 83.80 grams per mole, divided by the molar mass of our unknown gas. And I'm going to put A subscript 2 just to remind us that it is a homonuclear diatomic, like so. All right, so we've got to square both sides to get rid of that square root. So I end up with 1.49 squared equals 83.80 grams per mole divided by whatever the molar mass is of A subscript 2. Okay, and then I want to times both sides by the molar mass of A, and then divide both sides by that 1.49 squared. So I should get the molar mass of A subscript 2 is 83.80 grams per mole divided by 1.49 squared. All right, so let's just do some cheeky lines there and then work out what it is. So remember, that's the molar mass of the homonuclear diatomic A2. 83.8 divided by 1.49 squared gives me a molar mass of 37.75 grams per mole. So to work out what the individual atom is on the periodic table, I would divide that by 2. Okay, so if I divide that by 2, that will make it easy to find on the periodic table, which is 18.9. Okay, so if you look on the periodic table, fluorine has a molar mass of 19.00. Okay, grams per mole. So I think that's close enough. So my identity of my gas is difluorine F subscript 2. Okay, so just watch out for whether it tells you if the gas is made up of homonuclear diatomic molecules or if it's made up of just atoms.